All right, second try. So I have the backside of the integration by substitution worksheet, and we're going to go through some of the questions that people ask me, uh, or that I think people will possibly ask. So the first one I think would cause some problems is number 12 because it just looks different, and that's scary. So if you follow your same rule, though, let the trig value be your u, and then just go with it. So du is negative 5x to the negative 2 dx. Solve for dx. Those of you that skip this step every time when it comes time to finding something a little different to work it out, you won't know what to do. Not mentioning any names on film. You know who you are. So when I go ahead and solve for dx, I have du over negative 5, and then I have x squared. So I multiply by x squared. You can write at negative x squared in the denominator. I wouldn't suggest it. Now I just substitute. So I have the sine of u over x squared times dx, which is x squared du over negative 5. Cancel, cancel. And then you can finish it from there. It's pretty much the same as the other one, so getting it to that point. 16 is a lot like the one on the front. Let your radical x be the value. 15, if you can't figure out how to do a trig problem, try changing the form. So if you change the form here, this is really the tangent of x times 1 over the cosine of x, which is the tangent of x times the secant of x. And the derivative of secant is secant tangent. This is not even a substitution problem. So the integral is secant. Now, you can do this using substitution if you want to make life complicated, which I like to do sometimes. I'll just show you the steps here. You first need to write everything as in terms of sine and cosine, just like any other trig problem. When you get stuck, you write everything as sine and cosine. And so you let u be the cosine because that's our power, and then du is negative sine. Everything cancels out. You end up with, working your way through, u to the negative 1 plus c. Well, our u was cosine, so cosine of negative 1 plus c, which is the same as secant. So it actually works out. I don't think there are any other crazy ones on here except for the double substitution on number 14. But if you follow your rules, as long as you can take the derivative, you're okay. So I'm going to let sine of 3x be the u value. Du is 3 cosine 3x dx. Double check, make sure your sign's right, negative. Okay, integrate. So I have u to the 5th cosine 3x. Some of you are starting to see that you know you need to see that value here. Times dx, which is du over 3 cosine 3x. Boom, boom. 1/3 u to the 5th du. So u to the 6th over 6 plus c. So it's not really any worse than the other ones once you get the right value picked. As long as you can do this derivative without substituting again, you're okay. Further on down, shaded graph and words. So this is velocity. And so we're following, this is the position at any given time. So after 2 seconds, the area there is 2 times 2, which is 4. So we are at position 4. F of x would be 4, or S of x, or whatever you call a position function. And then right here, this is 2 by 2, which is a 1. So at 4, our position is at 5. And then we start to, so right here where velocity 0, we have turned around, just like before. And then after 6 seconds, your position is, that's a 2 by 2, so that's a 2. 2 less than where it was at. You're right back to where you're at. So that's how we will use integral of velocity to talk about the original function or y values. Average value of a function. Hopefully you didn't have to look this up. 1 over b minus a, integral from a to b. This was just a little review question, get 19. I'm going to show you the answers here on this, so you can check them. See if you have any questions. We will start in with some definite integrals. There's one extra step. And then also some applications, and kind of review all the integral stuff and have a ginormous integral test next week. All right, that's it.